I'm showing you everything, and then write down the 4 words to show me that you are not only writing what I'm doing, but you are listening too. So on page 30, these problems I'm assigning you, do the work, write down the 4 words. Here I go. So for these first ones, they're having you solve these literal equations. I'm rearranging this one for B, which you could see is an easy one. I'm just subtracting in one whole step this mx piece. So when that mx piece gets subtracted, that gives me y minus mx equals that b. So that is b all by itself. That's isolated. That's good to go. So b equals y minus mx. That is b. That is your y-intercept. Usually we'll solve one of these for x or y. The first word is did. Did is the first word. Okay, second problem has you solve for r. Seeing that this is 2 times pi times r. So the opposite of multiplying by 2 and multiplying by pi is dividing by 2 pi. Divide that to both sides. These 2 pi's will cancel away and just leave you c over 2 pi equals r. Or r equals the circumference divided by 2 pi. Okay, number 20. I'm having you solve for that d right there. So a little bit trickier. I'm going to have you, instead of dividing this pi out, I'm going to have you first get rid of that dividing by 4 by timesing both sides by 4 times by 4 times by 4. These 4's will cancel away, and that leaves you 4a equals pi, the symbol pi, times d to the second power. Now at this point, the opposite of timesing by pi, dividing both sides by the symbol pi. Those will cancel away and give me 4a over pi equals d squared. Right here, to solve for d, the opposite of squaring is square rooting. If I square root this side, I need to square root the other side. That square root is an inverse operation to d squared. Those will cancel and just leave you plain old d. If I was taking the square root of 3 squared, that would just end up being 3. The square root of 3 squared, the 2 and the root cancel. For this, the 2 and the root cancel, and just leave me plain old d. And again, these are inverse operations, just like the opposite of multiplying is dividing. So my final answer is 4a over pi, all underneath the square root symbol, equal 2d. Or of course you could write it d equals the square root of 4a over pi. Not is the second word. Alright, here we go. Next page. The harder page. I want you to solve these for y, graph them, and then find the point where they intersect and plug it back in to check it. So here we go. This is going to be tough. So for 21, the y on top is solved, but this one I had to plus x to both sides to get that solved for y. I need these solved for y before you graph them. We want them in slope-intercept form. So the first one was good to go, y by itself. This one required one step, adding x to both sides. Now they're both ready to graph, where this one in blue has a y-intercept of 5 and a slope of 2. So I go up to 5 on the y-axis. That number in front of x, which is 2, tells me how far to go over and up. So from 5, right 1, up 2, right 1, up 2. Stair step the opposite way. Left 1, down 2, left 1, down 2. Draw your line and label it. That line is y equals 2x plus 5. Alright, this next one I'm going to do in red. This one has a y-intercept of positive 1. The number in front of x is 1, so that made into a slope 1 over 1, over 1, up 1. So from 1, over 1, up 1, over 1, up 1, over 1, up 1, stair step the opposite way. Left 1, down 1, left 1, down 1. Draw your line through them. Label that line. And then make sure you get the correct point. I can see right there I made a little mistake. That is the correct point. -4, -3. That is where those two lines intersect, where -4 is your x and -3 is your y. Now what we're going to do, we're going to prove that this point is a solution to both these equations. I'm going to plug that x number into both x's, and I'm going to apply that y number into both of these equations y. So here I go. When I do the check, this first equation, where y used to be, I put in -3 from this coordinate. I have 2 from the original equation. Where x is, I put -4. I still have +5 right there. And that gives me -3 equals -8 plus 5. That is a true statement. -3 does equal -3. For the next one, what I did is I plugged in to this equation. For x, I plugged in the -4 into that -x. And for y, I plugged in -3. So again, I took this point, plugged it into this one's x and y, and then I took that same point and plugged it into this equation's x and y. I could have, of course, plugged it into this one that's rearranged, but I'm going back to the original. So where that x is, I put -4. Where that y is, I put -3. That becomes +4 minus 3, which is 1. That point is a solution to both of those equations. Okay, next problem. You need to solve both these for y. So this one, to get y by itself, all I need to do is take away that 10 to both sides. Cancels away, and that gives me y equals 3x minus 10. Can't subtract those. Get in the habit of writing the x term first. This next one, minus 2x. We'll get that one's y all by itself. Minus 2x, minus 2x. That gives me y equals -2x plus 0. So they're ready to graph. First one, it's got a y-intercept of -10 way down here. The slope in front of its x, which is 3, 3 over 1, over 1, up 3, over 1, up 3, over 1, up 3. Again, I got the y-intercept from this number, first point. I got the slope 3 over 1 to write my other points, over 1, up 3, over 1, up 3. That should be 3x minus 10. This one's got a y-intercept of 0 and over 1, down 2. Again, trying to show you how I'm getting that slope from 3 over 1, how I get that slope from -2, -2 over 1. Right 1, down 2, right 1, down 2, right 1, down 2. Draw your line. The third word is kick. Kick. Alright, that is -2x plus 0. That point right there where they intersect is the point 2 for x, -4 for y. So now the check, I'm going to take this point 2, -4 and plug it into both these equations for x and y. This point should satisfy both equations since it's the solution to this system. So the check will prove it. So here I go. The first one, 10 plus where that y is, I put that -4 in there, equal to 3 times 2. That should be a true statement. Plugging in y is -4, plugging in x is 2 into this original equation. Gives me 10 minus 4, which is 6. That is true. 6 equals 6. 10 minus 4 equals 6. That is true. That point satisfied that first equation. Now I'm going to plug it into that second equation. So that will be 2, where that x is. I'm going to plug in 2 plus that y number, which is negative 4. And that gives me 4 minus 4, which is 0. That is true. That point satisfied both equations. Last one. This one, take away x, minus 1x. We'll get that y by itself. Minus 1x. That equation is y equals negative 1x plus 9. That's negative 1 right there. Negative 1 over 1. This one, got to do 2 steps. Take away that x. Be sure to bring down the negative with the y. Negative x minus 7. And then right there, can't have that negative y. Divide everything by negative 1, which crosses that out and gives me y. Makes this positive 1x plus 7. So when I graph them, I'm going to go up to positive 9. I'm going to recount that. I think I counted wrong before. So positive 9 going up 9 on this 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the slope of negative 1 over 1, right 1, down 1, right 1, down 1. That is my line. Y equals negative 1x plus 9. My other equation, 1x plus 7, go up to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. This one's slope is 1 over 1, over 1, up 1, over 1, up 1. You should see that those two lines intersect right here at the point 1 for x, 1, 2, 3, 4, 5, 6, 7 for y. That is the point where those two lines intersect. That point should be the solution to this system. And again, I'm sorry, that is 1, 1, 2, 3, 4, 1, 8. I'm sorry, 1, 8. So for my equations where that x is, I'm going to skip ahead here. Where that x is, I put 1 in there because 1 is x. Where that 9 is, where that y is, I put 8 inside there. Let's fix that a little bit. And then, of course, that 1 where x used to be and that 8 where y used to be gives me a true statement. 9 equals 9. If I take that and plug it into the next one, 1 right there, minus that 8 for y, that should equal negative 7. That is another true statement. So that proves that point is a solution to that system. The last word is cat. Cat. Good luck. Make sure in my Math 1 Honors classes you are documenting today's classwork. Math 1 Honors. Good luck.